Friends, welcome to second lecture of the organic chem reaction series, in which today we discuss some previous year example from the CSIR-NET and GATE exams on the Birch reductions. Now let's take the first example. Question number 1. The major product of the following reaction is. This question asked in the GATE 2008 exam. Okay. Now let's solve this question. Before solving the question, we know that the on Birch reduction of the alkyne gives the trans product through. Okay, so let's draw the mechanism for the proper understanding. Okay, solid electrons from sodium in liquid ammonia. Okay, sodium in liquid ammonia, this is the sodium in liquid ammonia gives solid electrons. It attack over here and gives the radical anion like this. This is the radical anion. Okay, this radical anion abstract the protons from ammonia because it is enough basic to abstract the proton from the ammonia molecules. Okay, then again add the second solid electrons over this radical anion, over this radical, or the position at which the radical is present. We get the three. Okay, this is the vinyl anion. Vinyl anion is present or stable in the transform. After that, it abstracts the hydrogen from ammonia. And we get the final product. Okay, so on the Birch reduction of the alkyne, we get the trans product. Okay, let's see the option. In first option, it's not correct. Second, it's not correct. In third option, we get the trans product. Okay, this is formation of the trans product and not the cis product, which is shown in the D option. Okay, so our option is C. Let's see the question number second. In question number second, example is given in the line, that is reaction of meta-anisole with lithium in liquid ammonia. First write the step by step. Meta-anisole. What is structure of meta-anisole? Like this one. OMe, meta position to the methyl groups. Meta-anisole. Reaction of the meta-anisole with lithium in liquid ammonia and tertiary butyl alcohol. Lithium in liquid ammonia and tertiary butyl alcohol is the condition for the Birch reductions. Lithium in liquid ammonia in tertiary butanol, and temperature condition is minus 33 degrees centigrade. Okay, now in a previous lecture we see the when electron donating group present on the aromatic compound, it gives the Birch reduction in uniform manner at ortho and meta position. Now here there are the two electron donating groups, that is methyl, and one more is OMe groups. It is a more electron donating as compared to the methyl groups. In this example, we consider both the groups for the reduction. Now let's OMe, with respect to OMe groups, we get the reduction here. This is the meta positions with respect to OMe, is the ortho positions. That is a one full manner. and with respect to this CH3 group, we get the reduction, ortho and meta position. So our product is like this. The detailed mechanism in previous video on the Birch reductions. Okay, or let me explain just basic things. Okay, then OME here, radical anion form. After that it extract the proton from solvent, tertiary butanol. After that we get this reduced form. OME group here. Again second electron transferred to this position, that is meta position of the OME and methyl groups. We get OME anion, and this anion abstract the proton from the solvent, that is a tertiary butanol. Tertiary butanol, and we get the product. Okay, this is our X product. Now see in example, reaction of meta-anisole with lithium in liquid ammonia and tertiary butyl alcohol at -33 degrees centigrade generate compound X. We get the X compound, okay, as the major product. Okay, then treatment of the compound X with dilute H2SO4 at -33 degrees centigrade generates compound Y as the major product, and the compound X and Y respectively. Okay, we also find the Y. Okay, let's on treatment of this X of H2SO4. So conjugation through it abstract the, or it get proton from the acid. We get here double bond. Okay, and here is OME groups. It also stabilized through this. Again this compound take a proton via conjugation. It is a long conjugation proton abstraction. Double bond here. Okay, again it is a positive charge. Now the next step is addition of water molecule, or sorry, not addition, it is a nucleophilic attack of the water molecule. There is a two way, that is from these positions or oxygen carbon sigma bond through the methyl groups. Now question arises in your mind that the very water attack, this is the more electron deficient position as compared to OME, oxygen OME, and pi bond is less stable, and sigma bond is more stable. So our attack takes place at these positions, and we get OME water. After that is protonated, and we get the final product. Okay, this is our Y. Now find this X and Y in the option. Okay, this is our X, this is the Y. This is the not is Y, is the option D is correct. Now let's move toward the next question. The major product P of the given reaction. The question asked in the GATE 2005. We know that in the alpha beta unsaturated systems, the Birch reduction reduces the only alpha beta double bond and not the carbonyl groups. Okay, now see the option. In option E, this is the attack of the NH2, not possible. In second option, attack of the solvent, this is a solvent molecule, not possible here. We get the correct option is option number C. Okay, so, mechanism is similar like this. Electron transfer on here. We get the OMe, this electron, this is a bond. It abstracts the proton from the tertiary butanol. H radical anion. Again second electron transfer here. We get this anion OH. It abstracts the proton from the solvent again in this position. So it is OH. Okay, and we write this keto form of this group. We get this product. That is option number C is correct. Now see the question number 4. The reaction is an example of, ask in the GATE 2007 example, benzene plus 2 sodium, 2 molecule of the alcohol in lithium in liquid ammonia. It is this total condition is for the Birch reductions. So option A is correct answer. Then move towards the question number 5. The major product formed in the following reaction sequence is. The first step is, here is a structure of the meta-anisole, and we see the mechanism in the previous example of the meta-anisole gives the product. This is the ortho and meta with respect to OMe groups. It is electron donating groups. So and again with respect to CS3 groups, the reduction happen in one manner like this, as this position here and here. We get OMe CH3. Okay, then in second step, metachloroperbenzoic acid, that is MCPBA. MCPBA, the double bond which is more nucleophilic attack on the metachloroperbenzoic acid. The mechanism is like this. So double bond O, benzene ring. This is the meta position of the chlorines. First, this double bond attack here, electron deficient oxygen. Then it abstract the hydrogen, and again this bonded electrons attack over here. We get the final product. OMe, here is the ethyl groups. Now see in our option, there is option C is correct option for this reaction. Okay, this is the MCPA gives the stereospecific reactions and more reactive or more nucleophilic double bond attack on the MCPA. Then second question, or question number 6, the major product of the following reactions. In this example we have two systems, that is aromatic and alkyne systems. With this is the sewage groups, it is electron donating groups. Now we know that in case of the electron donating groups, the reduction happen at ipso and para positions, and in case of the alkyne systems, Birch reduction gives the trans product. We see in the previous questions. Okay, now we get the product like this. With respect to electron withdrawing groups, it gives the 1,4 product, and Birch reduction of the alkyne gives the transalkyne, that is a partial reduction of the alkyne. So find the correct option using this product. This option is option A, in which here is cis product, but we get the trans product, so option A is correct answer. Then move towards the question number 7. The major product formed in the following reaction. This is the quinoline. The reaction of the quinoline using lithium in liquid ammonia. It is a Birch condition. Okay, and we see in previous lecture that when an aromatic bicyclic systems, whenever the aromatic bicyclic systems present, the electron deficient ring reduces first, and or only electron deficient system reduces and not the electron rich ring. Okay, so here nitrogen is electron withdrawing. Lone pair present on the nitrogen is not delocalized over the rings, and it is a heteroatom which moved electrons towards itself. So we can write the mechanism for this reaction. Okay, it is an electron deficient ring. This ring is an electron deficient ring. So the solid electron transfer at these positions, it abstracts the proton from the solvent or ammonia. Sorry, in solvent, this is a tertiary butanol. It abstracts the proton from the solvent. We get this is the final product, because we see the such mechanism in previous questions. Okay, electron withdrawing groups gives the 1,4 Birch reductions at ipso and para position, we see in the previous questions. Now let's move towards the question number 8. The compound that form in the following reaction sequences. Okay, here is an methoxy group present on the aromatic compound. Methoxy group is an electron donating groups, so Birch reduction happen with respect to donating group at ortho and meta position of the electron donating groups in 1,4 manner. So our first product is I can't repeat the mechanism because we see in the last questions. Okay, after that second condition is 10% of the H2SO4, aqueous H2SO4. Then it by conjugation it abstracts the hydrogens. This is the mechanism for the second steps. We are not repeating the mechanism for first steps. Let's see in the last question. So after that, this is proton stabilize here, again OME, okay. It's the ring isomerization. It abstract proton of the acid, from the acid we get the double bond OME. Okay, it is carbon. Now again water molecule from the acid attack at the carbonyl center, electron deficiency center, we get OME here, OH, sorry, it again abstract the protons, like this. This is our final products. Right. Option number D is the correct option. Now then question number 9. The major product formed in the following reaction. In previous question, that is I think question number 6 or 7. Right. Okay, question number 6. That is the Birch reduction of the quinoline, and here is a Birch reduction of the indole systems. It is a totally different. Okay. Now in indole, lone pair present on the nitrogen is in the conjugation, so it's the nitrogen is not acting as an electron withdrawing, it is act as a electron donating groups. So this ring is electron rich ring, and reduction happen at the electron deficient benzene rings. Now let's see the mechanism for this reaction. Now in our solution, solid electrons as well as ammonia, that is the liquid ammonia, is present in the solutions. Ammonia has enough base to abstract these protons. Firstly, we get the first step product. Okay, then solvent electrons attack at the positions and stabilize in one form manner. This is the electron. Sorry. Okay. Then it abstracts the proton from methanol. We get this negative charge. Again, second electron at these positions. form the anion, and it abstracts the proton from methanol. To work up. This is the final product. In the okay, at this stage also the is abstract the proton from the methanol. This is the correct. Okay, now it's correct. So see, the option is option number 4 is the correct option for this question. Now move towards the question number 10. The major product formed in the following reaction is. This question, the first step is similar like the above reaction. In case of the pyridine or 2,5-disubstituted pyridine, it is an act as electron withdrawing groups. Withdraw electrons towards the itself. Nitrogen of the pyridine withdraw the electron towards the itself. So solid electron transfer here and stabilize on the nitrogen. It abstract the proton from tertiary butanol again, addition of the second electrons for this position. Okay, again it abstract the proton from the solvent. Okay, now this is up to this steps. It is our Birch reductions. After this stage, there is a KO. Second condition is the S3 positive, and third condition is the KOH and methanol. It is a condition for the Robinson annulations. You try this mechanism. Okay, we try this mechanism and also solve this question. Then we move towards the question number 11. Birch reduction of the compound. Okay, this group act as electron donating groups. So Birch reduction happen at this ortho and meta position with respect to electron donating groups. The solid electrons add over here, stability in this position. It abstract the proton from the solvent. We get this is the latest form. Again second electron transfer here Okay, this also abstract the proton from solvent. Okay, okay, here we get the conjugated systems, and one is the isolated double bond. Now Birch reduction react on the conjugated systems and not on the isolated double bond. So again, solid electrons attack at these positions and take the protons. This anion, sorry, there is formation of the anion in first steps. We see the step by step mechanism. And this abstract the proton from tertiary butanol. We get the final product. Sorry, this is not final product. Okay, so see the options. In option number D, we get the product. Now always remember the one things, the in Birch reductions isolated double bond never reduced in the Birch reductions. So we can stop here. Thank you.